Okay, check these last three. Make sure they went well. That uses each of our rules. If those went well, then you're on a great start. Hopefully those did go well. If not, again, please raise your hand so I can come talk to you and we can figure out what you're missing on the concepts that we just went over. Okay, I want you to take the next sheet that you have, the notes and practice. Okay, this continues introducing a little bit and helps you to understand some of the concepts, but it also gives you more practice. So we're going to continue working here. Okay, I've been using words to help me describe the values that are part of the problems, and I want to make sure we're clear on what each of these words are. So a general power is this whole set of values. So here we have a little bracket indicating the whole thing. That's called the power. Okay, the power is everything, that A and that B and the X all together. This X here, written up high, is the exponent. The number that has the exponent applied to it is the B, and that B is called the base. And then what we're multiplying that base to a power by, that A, we've seen that before when we're multiplying a variable, but now we have the variable in the exponent, or possibly in the base. We call that the coefficient. Okay, hopefully that's a familiar term for you. Okay, but I wanted to have that written out so we can clearly understand these words that I've been using so far. So it says here to take these and rewrite them as exponents. I'm going to let you try those. I'm going to give you a little hint on C and D before I let you finish it on your own. Notice C has different numbers. There's some 4s and there's some 5s. When I write the answer, I've got to write out 4, and then I've got to fill in a power there. And I've got to have times 5 and fill in a power there. Okay, I can't combine those two bases. I need to keep them separate. There are a couple 4s, there are a couple 5s. Figure out what the power is on 4 and what the power is on 5. Okay, also for D, notice they're in parentheses. That parentheses is very important. That's telling me I want to multiply that negative value repeatedly as well. When I write my power, I need to have the parentheses around the -1. Without the parentheses, the negative is not included in the repeated multiplication. So then you'll have -1 and you can fill in your power there. Okay, so I'm going to let you take a moment, go ahead and complete 2. Once you've completed it, start the video back up, and then we'll continue on. Okay, hopefully you have 2 done. We'll be checking those answers with me later. We're going to go on to number 3. I'm going to give you some hints with that, and then I'm going to have you try it. Okay, I don't want you to get confused at the first one because it's really not asking for much. X, there's nothing I can do with an X. It is X. Here again, same thing. X is just X. This is something we need to be clear on the difference between. If I'm adding, I add like terms, and X are like terms. We ask how many X's do we have in total? Well, there's 1 here and 1 here. Adding those together, we have 2 X's. Repeated addition is multiplication. Repeated multiplication is an exponent. When I have X and I multiply it by X, in order to write that in a shorter form, we use an exponent. There's 2 of them, so I get X squared. Okay, I'll let you finish. Go ahead and pause and finish those last 4 blanks. Okay, hopefully you've completed those, and now we're on to number 4. 4 is asking us to figure out what is the base. Or no, what is the exponent. Okay, we want to write the following in an exponential form. We just have to trial and error, guess and check. If I'm going to use a base of 5. So 625 can be written as 5 to some power. We got to figure out what is that power. And so you've got calculators there. It's a matter of doing some guess and check. Set it up so we can see again. There we go. So I'm going to try my powers of 5. I know 5 squared is 25, so I'm not even going to start there. I'm going to do 5 to the 3rd power. 125, not big enough. So I'm going to try 5 to the 4th. There it is. 625 was 5 to the 4th. So I'm going to go ahead and write it as 5 to the 4th. Okay, your turn. Try and figure out the last two. Okay, hopefully you have those last two completed. Again, make sure you're pausing as you need to. We're going to go on to finish this page. Here's written in the form of an equation, though. Similar idea, but this time we want to know what's the base before we had to determine the exponent. This is asking me what's the base. Something to the 5th power comes out to 243. For a 5th power, 243 is not a very big number because something multiplied to itself 5 times came out to 243. So maybe I need to do some guess and check there. Okay? And we use our calculators to help us with that. Maybe I'll try 2 to the 5th power. Okay, I can't see that very well. Let me set up my paper. There we go. 2 to the 5th power came out to be 32. All right, we need something bigger than that for sure, so I'm going to try 3 to the 5th power. There it is. 3 to the 5th power is 243. So the missing value, that n, that unknown base, needs to be 3. So in this case, n is 3. Okay, I'm going to let you try and do guess and check to fill in those last 3. Okay, just use your calculator, try and make some guesses, think logically, and figure out what you would need for those last 3. Okay, hopefully you've finished those 3. Now we're going to go on to the back side of the paper. We're going to continue to work to write things as simplified as possible, so we're using our rules of exponents. You've seen this before. This is like what we did on our note sheet. I want you to go ahead and see if you can fill in column 1, fill in the blank, 2 times 2 times 2 times 2 times 2. That should be a bunch of 2's multiplied together. In fact, there's 5 of them, so our shortcut is to write it as 2 to the 5th power. Notice how column 2 relates to column 1. Here, 2 times 2, that's our 2 squared. 2 times 2 times 2, that's our 2 cubed. Okay, if we were to put that in our calculator, it would come out to 32. But that's really just 2 to the 5th. Okay, we're going to try it here. Okay, you have 3 times 3 times 3 times 3. Well, that's the 3 to the 4th. Here's our 3 times 3. That's our 3 squared. We see there's 6 3's there, so I have 3 to the 6th, because that's what the exponent tells me, is I have 3 multiplied by itself 6 times. And so 3 to the 4th times 3 squared. If I put it in my calculator, it's going to give me 729. But in exponent form, that is 3 to the 6th. Okay, you finish this last section for number 6. Okay, hopefully you came back and you have completed all of number 6. If you haven't, again, pause. Okay, here we're going to go ahead and look at the next section. It's using our rule that we know. Remember our rule. Our rule is that when I'm multiplying x to the a times x, not b, how about x to the b? Times x to the b. What do? Hopefully you're thinking we add those exponents, x to the a plus b. Okay, so we're going to use that rule for these 9 problems here. I want to go ahead and do one of them with you. Okay, I'm going to let you do the first one, but I want to go to b. If I have a times a squared, what is the exponent on a? Okay, hopefully you're thinking 1. When there's a value written without an exponent, the exponent is 1. It's just that number itself. And so when I add those exponents, I get a to the 3rd. Okay, that should make sense because I have 1a here and 2 a's here, so there's 3 a's here in this problem, all multiplied together. Okay, go ahead and pause and finish number 7. Okay, welcome back. Here we're looking at some powers of a power. 2 squared to the 3rd power. This is what we saw in our note sheet before. So again, it's that idea of writing expanded and getting the idea of what's going on. But we're expanding it a little further here, so this might help you understand it even more. First of all, this outside exponent, they went for the inside first. So another way to do it is to think about the inside. 2 squared is 2 times 2. And then that 2 squared, that 2 times 2, has to be repeated 3 times. So I have a 2 times 2, a second 2 times 2, a third 2 times 2, and I see I have a total of 6 2's. Okay, so hopefully you got the idea. Let's do one more together so you can see. Another way to approach this, to think about it expanded, is to expand the inside first. Here I have 2 cubed, which means I have 2 times 2 times 2, 3 of them. That's expanding the 2 cubed. Now we're going to notice that that's squared. So here's my squared. Squared means multiply it by itself. So I need one of these and a second one of these. I need the first 2 times 2 times 2 and the second 2 times 2 times 2. Notice there's 6 2's, so we get 2 to the 6 as our power form and our exponential form. Okay, you try those next two. Pause it and then come back. Okay, again, hopefully you notice that rule show up again. If I multiply this case, when I have a power to a power, I multiply. 3 times 2 gives me 6. If we switch the order of what's on the inside and what's on the outside, 2 times 3 still gives me 6. You should see that rule here as well with your results from C and D. So our general rule is that x to the a to the power b asks us to multiply our exponents, multiply the a and the b. And so use that rule to complete these last 3 problems. Once you're done with those, please raise your hand so you can check your answers to see if you did all of this correctly.